Hello. In this video, we're going to go through Learning Target 6.3.2, which is writing the explicit formulas for given sequences. So for our sequences, here are two that we talked about before: arithmetic, which is where we're adding, and geometric, where we're multiplying. And these are their formulas, which we will give you these on tests. You just have to know which is which. So because arithmetic is adding, there's an addition sign. And because geometric is multiplying, there's multiply sign or parentheses. So first we just need to talk about like what each of these parts means, because these are variables we haven't really seen before. So when we have like not an exponent, kind of like the opposite of an exponent where it's at the bottom, this is called a sub. So like a sub n or a sub 1. And so a sub n means the nth term. So in the sequence, if we're asking for the 100th term, you would have a sub 100, and that's what you would use to try to find that term. So a sub n is just a particular term. In that case, a sub 1 would then be the first term, because it's a sub 1. D is our common difference. And then n is like the number that we're looking for. So in that example where I said if we're looking for the 100th term, it would be a sub 100. We would plug in 100 here, because that's our n. So now really similar in geometric sequences, they're almost exactly the same. A sub n is the nth term. A sub 1 is the first term. The only difference is that we have r is our common ratio. So these formulas can be really useful to find terms that are not right away. So in our examples from earlier, we did like find the next 3 terms. Well, the problem comes across if like I want to find the 3000th term. I don't want to find all the terms leading up to that. I don't want to spend all that time getting up to the 3000th term. What I want to do is just be able to find it, knowing that the sequence repeats. And so to find the nth term, you want to plug in your desired term for n, and then you just solve. So again, if I wanted to find the 100th term, I would plug in 100 here and 100 here. Same thing over here, in for n, and then I'd be able to solve. The other thing that we could do is ask for a missing value. So it'll give you a sequence and then like a value here would be missing or something. You can use the difference or the ratio to find that missing term. So you can either use it to work backwards or forwards to find a missing value. So in these examples, we are going to write the explicit formula and find the 25th term for the sequences. So writing the explicit formula means we want to fill in everything we know to here and simplify. So my first step, just like with the 2.0 level, is I need to figure out if we have an arithmetic or geometric sequence. I need to know if I have D or R, and then which of these formulas I should use. So the first thing I want to do is I want to see if I'm adding each time or multiplying. And so since the other thing you can look for to kind of have a hint is whether they're changing very fast. So you can see like these numbers are not changing very fast. -6, -8, -10. If they're slow, they're probably arithmetic. If they're fast, they're probably geometric. So I think this one's arithmetic. I'm going to try it out by subtracting -8 minus -6 to get -2. -10 minus -8 to get -2. And -12 minus -10 to get -2. So because I was subtracting, this is arithmetic. And that means we're going to use this formula. So I'm just going to write that down for now. And now I'm going to plug in the things that I know. So when I'm writing the explicit formula, you are going to fill in a sub 1 and d, and then simplify. Those are the only two things you can find for the explicit formula. So we're going to leave a sub n as it is. A sub 1 is the first term. It just means the number out front. So this is -6. And then d is our common difference. So I'm going to do either plus -2 or -2, parentheses, and -1. Now we can simplify this by distributing. So we're going to do that because we want our formulas to be as simple as possible. So we're going to distribute our -2 to get -2n plus 2. And then we can combine our like terms. So we're going to have a sub n equals -2n, and then -6 plus -2 is -4. And so this is as simple as I can get. I've got no more parentheses. I've got no more like terms. So this is my formula for my sequence. Now, the reason I want to simplify it is because I'm going to need to find the 25th term. So the simpler my formula is, the easier I'm going to have to find the term that I want. So if I'm trying to find the 25th term, I'm just going to plug in 25 for n. So a sub 25 is -2 times 25 minus 4. When we multiply, we get -50 minus 4. And then combine these together to get -54. So the 25th term is -54. And I didn't have to spend all the time like counting each one to see what the 5th term is, then the 6th, then 7, then 8, all the way up to 25. So now we're going to do that again, but for this one. If you want to pause it and try it on your own and then see me go through it, you can do that. Otherwise, let's just go through it. This one, since there's a fraction there, I think that it's probably geometric because we're probably multiplying or dividing. And so 2 divided by 4 is 0.5, 1 divided by 2 is 0.5, 1/2 divided by 1 is 0.5. So we are multiplying, so it's geometric. So I'm going to use this formula this time. So I'm going to write that down. And now again, I'm only going to plug in my a sub 1 and my r for my explicit formula. So a sub 1 is the very first term, 4. R is our 0.5. And that's all I need to plug in. And I actually can't simplify the geometric ones at all. So once you just plug it in, this is it. Now for the 25th term, I'm going to plug in 25 for my n. And you can just type all of this into your calculator exactly as it is. So you can have 4 parentheses 0.5, and then in the exponent is 25 minus 1, or just 24. And you get this very, very small decimal. And so geometric sequences change very, very fast. When we ask for the 25th term or 100th term, it'll probably be very, very, very small or very, very, very big. So this is the 25th term. So to find the formulas, you just need to know which is which, that the one with the plus sign is arithmetic, the one with parentheses or a multiplication sign is geometric, and then you always just plug in a 1 and then either D or R for the formula. So the very last thing we need to do is like find missing values. So like in this example, it says find the missing value in the sequence. And so we want to make sure that we figure out what's happening. And I like to take a guess and then see if it works the entire time. Because we go from very small, 3, to very big, 192, I think it's probably geometric. So if it's geometric, then to get from here to here, -3 times what gives me 12? Well, then r is -4. You can also do 12 divided by -3, which is what we've been doing. Well, if r is -4, then 12 times -4 gives me -48. So let's imagine that that's my answer, -48. I want to make sure it works every time. So -3 times -4 should give me 12. And then 12 times -4 should give me -48. And then -48 times -4 should give me 192. So it has to work the entire time. Because mine does, that's the correct missing value. However, if it was arithmetic, if I look here to here, 12 minus -3 is 15. If I were to go with that premise, I would have -3, 12, 12 plus 15 is 27, and then 27 plus 15 is 42, which is not 192. So you can see how, like, you can make it all the way from here to here to here, but then if the last value doesn't work, it's not that one. So you have to make sure you double check if you're filling in missing values.